Dear friends, welcome back to my channel Easy Quality Learning with another video, that is out of specification. In this particular video, we will discuss how to handle the out of specification and what are the different stages of out of specification. So let us first see what are the contents of this particular video. So contents are guidance documents, scope of OOS, purpose of OOS investigation, phase 1A and B investigation, phase 2 investigation, phase 3 investigation, and finally conclusion. So first we will see what are the guidance documents which are available for this particular topic. First is investigating out of specification test results for pharmaceutical production. So this is a US FDA guidance which is available, and second one is MHRA guidance which is available, that is out of specification and out of trend investigations. So this presentation is published by MHRA. Then let us understand the definitions. Out of specification, results that falls outside the predetermined specification. So if you are having any specification like 90 to 110% or 95 to 105%, if any result is coming out of this limit, that is called as out of specification. Let us suppose that the specification limit is your 90 to 110 and your results are coming 88.5. So 88.5 is out of a specification. Then what is out of trend? For out of trend, result is not out of a specification but show significant variation from historical data. So let us suppose that our specification is again 90 to 110%, but normally we used to get the assay of this particular test in the range of 97 to 103. Suddenly we got one result that is 91.5. So this is not out of a specification result, but this is called as out of trend, because normally we were getting 97 to 103 and now we got the results of 91.5%. So this result will be called as a out of trend. Then scope of OOS. So for what OOS is applicable, this is shown in this particular slide. So whatever input materials are there which are used, for that OOS is applicable. In process stages, finished good analysis. So for finished good analysis, this is applicable. For stability analysis, this is applicable. And where it is not applicable, it is not applicable to pharmacopoeial test, where it is mentioned that how to handle the out of specification results in pharmacopoeia. For example, you can say DT, uniformity of content. In DT, uniformity of content, and in dissolution, it is already given that if you are having a failure on S1 stage, or if you are one tablet in failing in DT, then how you need to handle that particular part. So if you are having a failure on S1 stage, S2 stage and S3 stage also, then that result will be called as out of specification, and then investigation will be triggered over there. Till that time, it will be handled as per pharmacopoeia only and not applicable for target tests. So what are target tests? Target tests, you can suppose that you are drying some material in your FBD, and in between you are checking the LOD of that particular material. So that is target test. So let us suppose your limit is 1 to 2%, and in between you are getting 2.5, 2.8 results, and then again you are drying the material as per to getting the LOD between 1 to 2%. So whatever results you are getting before getting into target, they are called as target test, and these tests are not applicable for out of a specification. Then what is the purpose of OOS investigation? To ensure that product is safe, to find the root cause of OOS so that it should not happen again, to minimize the reoccurrence of the lab error, so your lab error can be avoided, to avoid the testing in compliance, to evaluate the impact of OOS and other batches. So these are the main purpose of OOS investigation. Then investigation process flow, how it works. So as soon as the OOS comes, then phase 1A, lab obvious error investigation is done. Then phase 1B, lab investigation, full scale investigation is done. Then phase 2 investigation, where manufacturing and lab investigation is there. Then phase 3 investigation, where impact analysis is done. Then what analyst has to do once the OOS is reported? Analyst shall report the OOS results to the supervisor. All the dilutions, reagents and glasswares used shall be preserved till compliance of the lab investigation. Then calculation shall be verified. Check the obvious instrument failure and look for obvious error. Nowadays, it is expected that unless and until your analysis is not completed and your results are not out and you are not assured that your results are correct, it is expected that whatever the glasswares, reagents and dilutions you have used, it should be preserved till the end of your result completion. First, we will discuss 1A, obvious error. So, obvious error, what can be the obvious error? It will be sample spillage, it can be power failure, it can be incorrect sequence and the vial placement, equipment failure. In equipment failure, leakage can be there, pressure drop can be there, bubble formation can be there, and back pressure can be there. These are the types of equipment failure, and this is not limited up. There can be some more also. Incorrect process parameter. So, if you have processed the chromatograms with incorrect method, or your method which you have entered into the chromatograph that is incorrect, so that is also possible. That also comes under obvious error. And evidence of the above parameter to be enclosed with the report. So, whatever we are saying that this is the obvious error due to which the failure has occurred, so we need to incorporate the evidence of that particular part. So, what can be the evidence? Evidence can be your pressure graph can be evidence, and whatever messages we are getting on message center for power failures or for door opening or for back pressure or for overpressure or for leakage. So, that messages can be taken as evidence and it can be enclosed with our investigation report. Then, if the lab obvious error is found, then the error shall be documented and reanalysis after the error correction shall be done. Results of reanalysis shall be reported and a suitable kappa shall be taken. So, this is the process of 1A obvious error. If we are not able to find any obvious error in the first 1A investigation, then we need to enter into the detailed lab investigation. Detailed lab investigation, it is 1B lab investigation. So, we need to discuss the test method with the analyst for possible error. We need to ask the analyst that what exactly he has done while handling this particular sample and how he has executed this sample, so that we should be able to know what can be the probable reason or what can be the possible reason of error. Then verify the validity of test method. We need to check whether the test method is valid or some obsolete version is used. Then correctness of the sample storage condition and sample handling. So, we need to also check whether the sample storage condition was correct or sampling handling was correct or not. Then sampling procedure probability of sample contamination. So, we need to see whether the sampling procedure which is employed for doing the sampling, it was valid or it was done by qualified analyst or qualified chemist or not, or there is any chances of sample contamination, that also we need to evaluate. We need to check analyst qualification, whether the analyst qualification is in line for the analyst who has executed this analysis or not. Then correct dilution and weighment of the sample shall be checked. So, dilution and weighment of the sample we can verify with our weight prints as well as with the stored glasswares, which dilutions which we have stored. So, we can verify those dilutions as well as the pipettes which are used for doing the dilutions, because many times it happens that instead of 200 ml we have used 250 ml of volumetric flask, or instead of 20 ml volumetric flask we have used 25 ml of volumetric flask. So, this happens many times. So, it is very important to verify the correctness of the glasswares used. Then column correctness and filter accuracy need to be verified. So, column correctness, what we need to check in column correctness, we need to check whether historically whatever column we were using for this analysis, whether the same column has been used or we have used different column in this particular analysis. Similarly, in column, we need to also check whether the packing was correct, whether the part number was correct, make was correct, or we have used some alternate make. Similarly, for filter also, we need to check the MOC of the filter and make of the filter, whether there is any change in these parameters or not. If there is any change, then we need to record that in our investigation report. Then working standard and reference standard need to be checked, that validity of working standard and reference standard is in line or not. Instrument calibration validity need to be verified. Glassware calibrations and pipette and volumetric flask need to be verified. We need to check whether all the glasswares which we have used are correct or not, or they are calibrated or not. Then balance accuracy need to be checked, that our balance was calibrated or in calibration range or not. We need to check the system suitability reports, and we need to check the system suitability parameter also, whether the system suitability parameters what we were getting historically, it is matching with those parameters, or there is some changes in the parameters that we need to verify. Verify the samples analyzed with OOS samples. So if we have taken this analysis in particular sequence, or number of samples are analyzed in this particular sequence, so we need to verify the results, responses of other samples also with the OOS sample, so that we can get some vital information. Then results of other tests shall be compared with OOS results. So let us suppose if we got the OOS in your essay, so we need to check the results of your uniformity of content. We need to check the results of resolution, so that we can correlate those results with OOS results. So we should be able to find some information with reference to our results. Then instrument method and processing method shall be verified with actual STP. So we need to verify the instrument method, that is what was the flow, what was the wavelength we used, what was your runtime, and other parameters which were fed to the instrument, whether they are matching with STP as well as they are matching with historical methods which are used or not. And we need to also check the processing method for processing of the chromatograms. Then check the history of the product with other similar OOS. So we need to check the history of this particular product, whether we got similar OOS in this particular product, or if yes, then what were the reasons identified, so that we need to check. Any other abnormal observation during analysis, we need to verify. Method validation shall be verified. We need to check the method validation, that how the method was behaving during the validation, and is there any change during the method validation, or whatever routinely we are getting, that also we need to check. If the assignable cause is found in lab investigation, then kappa shall be taken and reanalysis shall be done. If we found that some lab error was there, so we need to correct that lab error, and kappa regarding that lab error should be taken, and we need to do the reanalysis of that same sample. And after reanalysis, if the results are complying, we need to report passing results as well as OOS results, and decision shall be taken accordingly. If we are not able to find the assignable cause in lab error, then we need to enter into phase 2. In phase 2, we are having two parts. One is your manufacturing investigation, and second one is analytical investigation. So as soon as we enter into phase 2, we need to raise a deviation, and this deviation will trigger the manufacturing investigation. So first we will see how the manufacturing investigation has to be done. So in manufacturing investigation, we need to make an investigation team where the manufacturing person, who is the specialist of manufacturing, and your quality assurance person will be included. Doers shall be asked about what happened. So the person who has processed the batch, they should be asked how they have exactly processed the batch and what happened exactly. Then in investigation, first we will check materials. In materials, vendor evaluation shall be done with reference to the manufacturing location of the vendor, whether vendors are same for active ingredients and other critical ingredients. It need to be checked that whatever vendor we were getting historically, from same vendors we are getting the materials, or there is any change in critical material attributes. So in critical material attributes means if there is any change in particle size, or there is any change in nature of material, or some other vital information what we are getting from our operators and chemists, that can be taken into consideration for material attributes. Whether any observation is there in history with reference to material. So we need to check the history of the product, whether any similar failure is observed due to faulty materials. So that also we need to verify, and similarly we need to find the reason in this particular investigation also. Then Second part of investigation is man. The person involved in that are trained or not, that we need to verify. So, whatever chemist or operators which were doing the manufacturing activity, whether they were trained or not, that we need to verify with the documents. Whether the operator or chemist is making the product first time, so that also we need to verify that this product is manufactured at site first time or many times we have manufactured this product. Then manufacturing process. In manufacturing process, critical process parameter to be verified with the batch records. Critical process parameter means mixing time, granulation parameters, drying parameters, time, LOD, granule characteristics and mixing time. So, these are all critical process parameter which need to be verified with the historical data of other batches which were passing. Then compression machine speed, compression force and hardness of the tablet. This will also come as a critical process parameter. Then coating parameters like spray rate, viscosity of the coating solution. This need to be checked at the coating stages. Then primary packing, sealing temperature and machine speed and leak test. This need to be checked during primary packing of the product. Then measurements. We need to check the measurements. In measurements, we need to check environmental conditions to be verified. Hold time at each stage shall be checked, whether there is any abnormal holding of the product at any particular stages. Any abnormality in the physical parameters to be checked. Hold time at each stage shall be checked. Any abnormality in the physical parameters need to be checked. We need to see that there is any physical changes in your granules characteristic or there is any physical changes in coarse tablet. Then comes machine. Check for the major breakdown during the process. Then preventive maintenance and the qualification status need to be checked. We need to check whether the same set of equipments are used or not. This means that if we are using 600 liter of RMG, then we need to verify whether we have used 600 liter of RMG or we have used 800 liter for this particular processing. If we have used the detooling for compression of these tablets, then we need to verify that same detooling machine is used for compression of this particular product or we have used some other set of equipment. So, this we need to verify with the historical data. The manufacturing investigation shall be extended to the discussion with chemist and operator processed the batch for any other abnormal observation. This we already discussed. In manufacturing investigation, the processing of other batches of same product shall be checked for any abnormal observations. So, we need to verify the process parameter of this OOS batch as well as the process parameter of normal batches which we have processed earlier. So, if we were able to find any information from that. If any of the root cause is observed in manufacturing investigation, then based on it, the decision of reprocessing, testing or rejection can be taken. If no root cause is found, then analytical investigation of phase 2 shall be entered. So, if we are able to find any root cause during manufacturing investigation, then based on manufacturing investigation, we can take kappa and based on that, we need to take the decision on batch disposition. So, before processing for your analytical investigation, we need to understand hypothesis testing because this particular term will be used during your analytical investigation. So, what is hypothesis testing? Analysis done to confirm the probable root cause is hypothesis testing. So, whatever analysis we are carrying out for confirming the probable root cause, that is hypothesis testing. Hypothesis need to be prepared and approved by QA and QC before execution. So, QA and QC shall be in agreement what we are going to do in hypothesis. Acceptance criteria shall be predefined in the hypothesis before execution. Retesting in the hypothesis shall be done by different analysts with equivalent or more experience. So, whatever analysis or whoever is doing the analysis of your hypothesis testing, you should have a more experience than the person who has generated OOS results. These are the probable hypotheses which can be generally executed depending on your investigation. So what can be the probable root cause? Probable root cause can be improper sonication. Then what action we need to take? Resonicate the existing samples. Then improper transfer can be there. So in improper transfer, we can redilute from the existing stock solution. Wrong vial placement can be there. So same solution shall be filled in the new vial and then it shall be injected. If filter interference is suspected, then we need to refilter the final solution. Then retesting of the same sample can be included as a part of analytical investigation to rule out any unknown error in the analysis. So this can be the probable root cause and this can be the probable hypothesis for doing your hypothesis testing. So first we need to prepare hypothesis protocols with predefined acceptance criteria, and based on that we need to pre-approve this and then we need to execute this hypothesis testing. Then phase 2 investigation analytical part, how we are going to do. If no assignable cause is found, then retesting of the same sample can be considered with predefined acceptance criteria, which we have discussed earlier. Analyst having same or more experience shall do the retest. So this is the second condition. Then 6 retests shall be done for the same sample. Then same sample shall be used for reanalysis. We should not take another sample for doing reanalysis, or resampling should not be done at this stage. If all the results confirm the OOS results, then OOS shall be considered valid and batch shall be recommended for rejection. If whatever 6 analysis we have done, and in this 6 analysis also we are getting the out of specification results, then it is assumed that whatever OOS results we have found at initial stages, it is confirmed and it shall be recommended for rejection to Quality Assurance Department. If all the results are well within the limit, the percentage RSD shall be determined and the results shall be checked with previous normal trend. So this is one more thing we need to verify, that if all the results are within the specification, then percentage RSD should be also be as per normal trend which we are getting earlier. Then if in 6 replicate analysis results are not precise, then averaging shall not be considered. So whatever 6 results if you found, let us suppose that in 6 results, one is 97%, one is 108%, 101%, one is 94%. So this type of scattered results are obtained, then we should not do averaging, because averaging will hide the variance in the sample. So this is the recommendation, that if the results are not precise, then averaging should not be done. The analyst 3 shall do the 6 replicate analysis to confirm the passing results obtained in the retest. If in second retest, if we are getting all the 6 passing results and results are precise, then third analyst shall verify or confirm those results which we have obtained in retest. Resampling of the batch shall be done in rare cases, like sample is exhausted in the initial phase of the analysis, then evidence is found that the sample is degraded or contaminated due to improper storage, like your color change is observed or your moisture gain is observed. So we can do the resampling. Manufacturing investigation suggests the need of reprocess. So if manufacturing investigation is suggesting that we need to do the reprocess, then after reprocess we need to take the sample. The sampling procedure is under question. If our sampling procedure which is executed, it is not done properly, then we can do the resampling. Then at the end of the phase 2, the decision on the batch disposition shall be taken. So by end of the phase 2, we need to decide whether what we have to do with the batch, whether it need to be approved or it need to be rejected. And while deciding the disposition of the batch, following shall be considered. Outcome of the lab investigation in phase 1. So whatever results are there for phase 1 investigation, that should be considered. Conclusion of manufacturing investigation, it shall be considered. Results of hypothesis testing in phase 1 and phase 2 shall be considered. And history of the product and similar OOS of the product, this shall be considered while taking the batch disposition decision. Then comes phase 3 investigation. So there is one obvious question, that if we have taken the decision of batch, whether it is to be rejected or whether it has to be approved in your phase 2, then why phase 3 is required? So Phase 3 is very important because in phase 3 we do not have the foundation of the reanalysis of sample. So for establishing the reason of rejection, we can do the number of analysis or number of retest, whatever is required in this particular phase. And this particular phase is employed for the impact assessment on other batches also. So that's why this phase is very important. So in phase 3, what need to be done? Manufacturing investigation and lab investigation shall be reviewed. As per the root cause identified, the impact on the other batches of the product shall be checked. Once the decision on the batch disposition is taken, then n number of retests can be done to establish the root cause and as a part of impact assessment. So that what we have discussed just now. And decision of batch disposition or batch rejection cannot be reverted based on the phase 3 analysis. So it should not happen that if we are getting the passing results in phase 3, then based on that, if some rejection decision is taken, that can be reverted. It should not happen, and that is not allowed. Then conclusion. All the results of the phase 1 and phase 2 shall be reported irrespective of the batch disposition decision. As per the root cause identified, kappa shall be taken. All the investigation report and raw data shall be enclosed with OOS document. Repeated lab error shall indicate the improper lab controls. Effectiveness of the kappa shall be monitored, that whatever kappa we have taken, how much that they are effective, it should be monitored. Then this is one flow diagram to explain how the out of specification is handled. So first is, if we have done the analysis of the sample and results are observed in a specification, no action is required. If the results are out of a specification, then we need to enter into phase 1A for obvious error. If we are able to find the obvious error, then we need to take kappa, then we need to do the reanalysis and the results need to be reported along with the kappa. If we are not able to find the obvious error in this particular investigation, then we need to enter into detailed lab investigation, that is phase 1B. If we are able to find the lab error, then after correction of the lab error, we need to do the reanalysis and reanalysis report shall be reported along with the kappa. If we are not able to find the lab error, no assignable cause is found, then we need to enter into phase 2 investigation where manufacturing investigation and lab investigation is done. So in phase 2 investigation, in manufacturing investigation, first we need to file a deviation, and based on deviation we need to trigger manufacturing investigation. Then based on the root cause identified, we need to take required kappa and decision on batch disposition needs to be taken. If we are not able to find any assignable cause in manufacturing investigation, then we need to enter into analytical investigation. In analytical investigation, hypothesis reanalysis need to be done or hypothesis testing need to be done. In hypothesis testing, if in retest all the results are complying as per specification and the results are precise, then we need to confirm the results with third analyst, and third analyst will do the analysis of same sample 6 times again, and if analyst 2 and analyst 3 are confirming the same results and all the results are passing and results are precise, then those results are reported to quality assurance department to be considered during batch disposition. If all the results in retest are observed confirming OOS results, then those results shall be reported to quality assurance department to be considered for batch disposition. Once the decision of batch disposition is taken, then phase 3 investigation can be triggered. In phase 3 investigation, we need to find the impact assessment on the other batches of same product, or if similar products are got impacted, so that also we need to check, and we need to report all the results and investigation findings along with out of a specification document. Friends, with this we come to an end for this particular video discussion. If you like the contents of this particular video, then press like button and share with others. Subscribe the channel if you have not subscribed the channel till date, so that latest updates can be obtained. Thanks for watching.